In this video, I will discuss JEE Main PYQs from the topic projectile motion. These questions have appeared between the years 2023 and 2021. Timestamps are given in the description box. You can watch parts of video if you're running short of time. I'll discuss some 8 questions. This is the first one. A stone is projected at an angle 30 degrees to the horizontal. The ratio of kinetic energy of the stone at the point of projection to its kinetic energy at the highest point of flight will be. You can pause and answer this question. So the projectile is thrown like this. You have a parabolic path and hit the ground somewhere here. So it's projected at an angle theta equal to 30 degrees. So this is point number 1, and the highest point will be point number 2. So the horizontal component of velocity u cos theta is same throughout. So even at this point, the horizontal component will be the same u cos theta. But the vertical component of velocity, which is u sin theta at the projection point, will become 0 here. So the energy at this point 1, kinetic energy at the point 1, with the total velocity square. But at point 2, the kinetic will have only the horizontal component, which is u cos theta square. Theta is 30. So this decrease in this kinetic energy has gone in increasing the gravitational potential because of the gain of the height here. So the ratio is 1 by cos 30 so which is 4:3. So option C is the correct answer. Option C. That's what I've done here. The stone is projected at an angle theta equal to 30 degrees and reaches the maximum height. So the kinetic at this point is half m u square, and at this point the horizontal component of velocity will remain constant, which is u cos theta. Same u cos theta will be here, but the vertical component is 0. So here the total velocity is u cos theta. So kinetic at the point 2 is half m u cos theta square. So the ratio is 1 by cos theta square, which is 4/3. So from here to here, there is increase in gravitational potential because of the gain of height. That has come at the expense of decrease in the kinetic energy, and that is the vertical kinetic energy. The horizontal component of the kinetic energy is same throughout. This is the next question. Two bodies are projected from ground with same speeds, 40 meters per second, at two different angles with respect to the horizontal. The bodies were found to have same range. If one of the bodies is projected at an angle 60 degrees with horizontal, then the sum of maximum heights attained by the two projectiles is dash meters, given g equal to 10 meter per second square. You can pause and attempt this question. So two bodies are projected at the same speed u. under angles theta 1 and theta 2, if the range is same, then theta 1 and theta 2 are complementary angles. This is a standard result which can be proved. So theta 1 is given as 60. So that means theta 2 is 30 degrees. To get the vertical height, we can use this equation of motion in the vertical direction. V square equal to u square plus 2as in the vertical direction. So this you can apply between the points, the initial point and the point of the maximum height. This is u and this is v. So the final point, the velocity is 0. Initial point, the y component is u sine theta square, and acceleration is minus g because upward direction is positive, and the displacement from between these 2 points is the maximum height h. So from this, suppose if we take the first projectile, it will be theta 1 and then h1. So this will be h1 as u sine theta 1 square by 2g, and h2 is same thing, but the projection angle is different, theta 2. So you have to find h1 plus h2. U square by 2g is common into sine theta 1 square, which is sine 60, and then half sine 30. U square is 40 square, g is 10. So this is 3 plus 1 is 4. The denominator is 4. This is 3 by 4 plus 1 by 4, it's 1. So 40 into 16 into 100 by 2 into 10. So 80 meters. Eighty is the correct answer. Both the projectiles have been thrown at the same initial speed 40, one at an angle theta 1 equal to 60 degrees, and they given the range is same. So that means that the second angle should be complement of this one. So 90 minus 60 is 30. We have to find the sum of heights. One way to get the height is v square plus u square plus 2a. Another way is to get the flight time from v equal to u plus 80. So v is 0, the maximum height point. U is vertical component 40 sine 60 minus g t1 by 2. T1 by 2 is half the flight time between the initial point and the maximum height point. So from this I get t1 as this one. Similarly t2, 0 equal to 40 sine 30, instead of 60 is 30, and then t2 by 2. So t2 is 4 seconds. And the height reached is half is equal to vt minus half at square. You can use that, where v is 0. So just half g t square, where t is the half the flight time. So from that we get h1 plus h2 as 80 meters. Here we have used the result that for the range to be same, the angle should be complementary, which can be proved. Range of the projectile is the horizontal component velocity into the flight time. The horizontal velocity component is constant throughout, uniform velocity, and the flight time you can get from v equal to u plus at between the initial point and the maximum height point. At the maximum height point, the velocity is 0, initial velocity is u sin theta, time is half the flight time. From that, we get the flight time as this one. Putting this thing here, we get the range as u square by g sin 2 theta. So for the range to be say for two angles, sine of the angle should be same, and we know that sine alpha is same as sine 180 minus alpha. So 2 theta 1 should be same as 180 minus 2 theta 2. Only then the sine will be same. So from there, we get the result that theta 1 plus theta 2 is 90 degrees. So for the range to be same, the angle should be complementary for the same initial speed. This is the next question. The vertical maximum height to which a man can throw a ball is 136 meter. The maximum horizontal distance up to which he can throw the same ball is. You can pause and attempt this question. So this person can impart an energy of half m u square to the ball, and that is going to increase the potential energy of value mgh, where h is 136 meter SI units. So from which we get the u square which the person can throw is m and m will cancel. Okay, in the second case, he is throwing at an angle, and the range of the projectile is u square by g sin 2 theta. Okay, he can throw the same u square because the energy imparted is half m u square. He'll throw the same energy, so the u which can impart to the ball is this one. So from here, I can get u square by g as 2 into 136, that is 272. And for the range to be maximum, 2 theta should be 90 degrees. So the maximum range is this many meters, SI units. B is the option. B is the correct answer. So the energy the person can impart to the ball is half m u square, which has gone in increasing the potential energy the maximum height point as mgh, which is 136. So from which we get the u square which the person can impart as 2g into 136. For the range to be maximum, this sin 2 theta should be 1. So in that case, the range will be u square by g. From that, you can get from this as 2 into 136 is 272 meters. Next question. A projectile is projected at an angle 30 degrees from the horizontal with initial velocity 40 meter per second. The velocity of the projectile at 2 equal to 2 seconds from the start will be. This is a simple question. So the projectile is projected with a velocity u equal to 40 meter per second at an angle 30 degrees. So at 2 seconds will be somewhere. The horizontal component of the velocity at 2 seconds will be same. So Vx at the end of 2 seconds will be same as Ux because x component is unchanging. That is 40 cos 30 degrees SI units. But the vertical component of the velocity will keep on decreasing, which is equal to u y plus at. A is minus g, and then time is 2 seconds. Initial vertical velocity is 40 sine 30 minus g into 2. This is half, so it is 0. Sine 30 is half, so this is 20. 2g is 20. So velocity at the end of 2 seconds will be only the horizontal component, which is 40 into cos 30, 20 root 3 SI units. Option D. (20 root 3 is the correct answer. Horizontal component, the velocity is 40 cos 30, which is 20 root 3, which is unchanged because there is no acceleration in horizontal direction. The vertical component will keep on decreasing from the initial velocity of 40 sine 30 minus g into 2. This is v equal to u plus 80 in the vertical direction. U is the vertical component, 40 sine 30, and then a is minus g, and the time is 2 seconds, which is equal to 0. So at the end of 2 seconds, the velocity will be only the horizontal component, is 20 root 3. Next question, the projectile is launched at an angle alpha with the horizontal with velocity 20 meter per second. After 10 seconds, inclination is with the horizontal is beta. The value of tan beta will be g equal to 10 meter per second square. So the projectile is launched with a velocity of 20 meter per second at an angle alpha. So we take a parabolic path. At 10 seconds, will be somewhere here. The inclination the initial inclination is tan alpha, which is dy by dx, which is same as vy by vx at any time. Because dy by dx can be written as dy by dt divided by dx by dt. So at initial time, this is uy by ux. Okay, so at 10 seconds, the vertical component of the velocity at 10 seconds will be initial velocity u minus g into 10. Initial y component is 20 sine alpha minus 10g. But the horizontal component of the velocity at 10 seconds is same as initial u cos alpha, which is 20 cos alpha. So tan beta is vy by vx at time t equal to 10 seconds. Vy is this one, 20 sine alpha minus 10g by u is 20 cos alpha. So it is tan alpha tan alpha by, so it's g is 10, so 5 times secant alpha. This is 100 by 20 is 5, and then 1 by cos is secant. So tan minus 5 secant is option B. B is the correct answer. So the horizontal component velocity is 20 cos alpha, which is same throughout. So it's same with the velocity at any time instant. But the vertical component velocity will decrease from the initial value 20 sin alpha minus g into time. So at 10 seconds will be g into 10. So tan beta is Vy by Vx at the time 10 seconds. So Vy at 10 seconds is 20 sin alpha minus 10 by this one 20 cos alpha. So 10 has been cancelled, g is 10. So they get tan alpha minus 5 secant alpha. This is the basic thing. Tan of the inclination is dy by dx, which is same as dy by dt by dx by dt. This is same as Vy by Vx. So to get the inclination of the trajectory, we can take the ratio of the velocities, y component and x component. Next question. The ranges and heights of two projectiles projected at same initial velocity at angles 40 and 48 degrees with the horizontal r, r1 and r2 and h1 and h2 respectively. Choose the correct option. Range 1 is greater than range 2, h1 equal to h2, r1 equal to r2, h1 less than h2, r1 less than r2, h1 less than h2, r1 equal to r2, h1 equal to h2. So they're comparing the ranges and the heights for the two cases. Here the projectile angles are complementary. 42 plus 48 is 90 degrees. So for the same u, for complementary angles, the range is same. So r1 equal to r2 because theta 1 plus theta 2 is 90 degrees, complementary angles. To get the maximum height, we can use v square equal to u square plus 2a's in the vertical direction. So the maximum height point, the velocity is 0. The initial velocity is u sine theta whole square, and then a is minus g, and the displacement is h, maximum height at the maximum height point. So from this I get h as u sine theta square by 2g. So h1 is sine theta 1, u is same, and h2 is sine theta 2. So whichever sine theta is more, so sine theta 2 is more than sine theta 1 because sine 48 is greater than sine 42. So h2 is more compared to h1. h2 is more compared to h1. So option B. B is the correct answer. Sine variation is like this. Theta equal to 0 degrees, this is 90 degrees. So in the first quadrant, as angle increases, the value of the sine will also increase. Sine theta versus theta. So 42 will be here, 48 will be here. So sine 48 is greater than sine 42. So h2 is greater than h1. So two projects of the same initial velocity, the range is same because the angles are complementary. So range 1 is u square by g sine 2 theta 1. Range 2 is sine 2 theta 2. So, and 2 theta is 84, which is 90 minus 6. And here 2 theta 2 is 96, which is 90 plus 6. And sine 90 minus 6 is cos 6. And 90 plus 6 is also cos 6. So the ranges are same, r1 equal to r2. Maximum height we can get from the v square equal to u square plus 2a, which is same as the energy conservation. Kinetic energy at the bottom point, the vertical one, has gone increasing the gravitational potential energy. So this is exchange between the gravitational potential energy and the vertical kinetic energy. So whichever sine is more, there will be more. Sine 46 greater than sine 42. So H2 is more than H1. Next question. A body is projected from ground at an angle 45 degrees with horizontal. Its velocity after 2 seconds is 20 meter per second. Maximum height reached by the body during its motion is dash meter. So it's thrown at an angle of 45 degrees with some initial velocity u. And after 2 seconds, the x component of the velocity vx will be same as u cos 45. But the vertical component of the velocity vy after 2 seconds, its initial velocity uy, which is u sine 45 minus g into 2. So velocity after 2 seconds is sum of these two. We have to square them, add them up and take the square root. So v square at 2 seconds is this square plus this square. So u square by 2 plus this square, which is u square by 2 minus u root 2 g into 2 plus g square into 4. And v2 square is 20 square. Hundred. So this is u square minus u 2 root 2 g. This is 400 and this also 400. So these two will cancel. So this will give me u into u minus 20 root 2. G is 10. This is equal to 0. So u is 20 root 2 meter per second. So maximum height we can get from energy conservation. Initial kinetic is half m u square as increasing the gravitational potential energy. So h is half u square is 400 into 2 by g is 10. So 40 meters. I made a mistake here. See this energy conservation, actually here mgh plus one more term is there, half m vx square, or x component velocity is there, which is 20 root 2 square. Or we can use this relation v square equal to u square plus 2ah in the y direction. So vy is 0, uy is 20, because total u is 20 root 2, 20 square minus 2 g h. So h will be 400 by 20. So it's 20 meters. energy conservation, initial energy is half m u square, final energy is mgh plus the x component kinetic energy. That also has to be included. That is same as this equation. So the projected at an angle 45 degrees. So the y component of the velocity will keep on decreasing as u minus gt. At the end of 2 seconds will be u sine 45, which is u by root 2 minus g is 10 into 2. So at the end of 2 seconds, the total velocity will be x component velocity, that's u by root 2 square plus y component vy square, that's equal to 20 square. So from this I get u as 20 root 2. So vy at the maximum height point is u square plus 2as. Maximum height point vy is 0. Initial velocity is u sine 45. So it's this divided by root 2. So 20 minus 2gs. From this height is 20 meters. This is the next question. The trajectory of projectile in the vertical plane is y equal to alpha x minus beta x square, where alpha and beta are constants and x and y are respectively the horizontal and vertical distances of the projectile from the point of projection. The angle of projection theta and the maximum height attained h are respectively given by. So angle of projection theta is dy by dx at t equal to 0. Angle of inclination at any time is dy by dx, but at the initial point you have to put t equal to 0. So y equal to alpha x minus beta x square. So this is x into alpha minus beta x. From here I'll get dy by dx is, you have to differentiate this one, alpha minus 2 beta x. At t equal to 0, x is 0, because this one y versus x, the trajectory will look like this. So the y is 0 at x equal to 0. So this is x equal to 0 and this is the y axis. So x equal to 0, y equal to 0, and at x equal to alpha by beta, then also y is 0. So quadratic equation 2 roots, one is x equal to 0, other one is x equal to alpha by beta. So this, by symmetry, the maximum way to the middle point, which is half of alpha by beta. So theta, you have to put t equal to 0. At t equal to 0, x is 0. So this is alpha. This is actually tan theta. Okay, so theta is tan inverse alpha. So h is the maximum height point, which is y at x equal to alpha by 2 beta. So here if you put alpha by 2 beta, or here also you can put alpha by 2 beta. So if you put alpha by 2 beta, so half of alpha by 2 beta, beta and beta cancel, so alpha by 2. So this will be alpha by 2, and here also there is 1. So tan inverse alpha and then alpha square by option 1. Option 1 is the correct answer. So the trajectory is given like this: y equal to alpha x minus beta x square, which is same as x into alpha minus beta x. So the trajectory look like this. The roots are x equal to 0 and x equal to alpha by beta. So x equal to 0 and x equal to alpha by beta will be y equal to 0. That is at the ground. So this is a parabola. So it will attain a maximum at the middle point. Middle point is half of alpha by beta. So the height, maximum height is same as the y value at x equal to alpha by 2 beta. So if you put alpha by 2 beta here, we'll get alpha square by 4 beta. Inclination of the projectile motion is du by dx, and that relation is given y versus x. So from this I get du by dx as this one, and theta is at time t equal to 0. That is same as x equal to 0, because at time t equal to 0, x is 0. So if you put x equal to 0, you will get alpha. So theta is tan inverse alpha.